All right, so this is Math 146. We are talking about section 6.1, parabolas. So if you watched the previous video, which was kind of the introduction to conic sections, this is one of the 4 basic conic sections that we're going to talk about. Again, we are not talking specifically about circles, but we are going to talk about parabolas, ellipses, and hyperbolas. So this section is parabolas. And if you remember, the general graph of a parabola, this is the one that we've probably used most frequently, looks something like this. Oops. Looks something like that. That is your standard parabola that looks like something like y equals x squared. And that's what we're kind of all used to dealing with when we're talking about quadratics. Quadratics are parabolas in shape. But now we're going to talk specifically about like the actual mathematical breakdown of what parabolas are, how you find the equations for parabolas, and so on, based upon the actual definition. So parabolas have multiple parts to them. They have the actual graph part, which is what you see there. But then there's also this point, someplace inside what I would call the concavity of the the parabola, which is called the focus. And then you also have a line, which is on the other side of the parabola, which is going to have an equal distance away from the vertex that the focus does. And that line is going to be, in this case, a horizontal line. That does not look very horizontal. I apologize. Okay, better. And that line over there is called the directrix. And the way a parabola is actually formed is that every point that lies on the parabola, it doesn't matter where it is going to be equally distant from the focus and the directrix. In other words, and this is the easy one, if I were to go up from the vertex, that is going to be a units away. So that would be the point 0a. Well, that means that the point down here is also a units away, but in the opposite direction. So that's going to be the point 0, negative a. Now that's the easy one because it's from the vertex. And in this case, because it's a standard parabola, the vertex is centered at the origin, and the parabola is not tilted or twisted or anything like that. So it makes it quite a bit easier because it's a simple vertical distance. But like I said, every point on the parabola is equally distant from the vertex and the directrix. So in other words, if I were to take this point up here on the parabola, the distance that I would take from the focus to that point should be exactly the same distance. Now my drawing is not very good. From that point to the directrix. So these are supposed to be congruent distances. Again, it's not the best drawing, and that's why it doesn't look right. But that is the idea. And then again, I can come over here, and I can put a point right there. So the distance from the focus, wow, to this point is the same distance to that point right there. I don't know why, but I am having the hardest time drawing that straight line from the focus to that point. That's a little better. And again, those are supposed to be congruent lines. So that is the definition of how a parabola is formed. It is every possible point that has an equal distance from the focus to the directrix. So that is literally the definition of a parabola. I could go through the entirety of how the general form of a parabola is going to be derived, but it's basically just using the distance formula. And you could probably look this one up if you're really interested. But the general form is going to be, and there's multiple forms because it's really going to depend upon which way the parabola opens. And I'm going to back up, and I apologize because I know I started a sentence and now you're probably thinking, what the heck is he talking about? When you look at the equation of a parabola, a couple things you want to notice. One of the variables is a squared, one of the variables is not. So basically what you are looking for is one linear term, in this case the y is the linear term, and then the x is the quadratic term because it's x squared. You will only ever have one of them be squared, the other one will be a linear term. If that's the case, then you have a parabola, you have a quadratic equation of some kind. Now it could also be in the form of x equals y squared or some form of that. If you see that, the only thing that happens now is that the parabola, instead of opening up or down, is going to open left or right. And we'll discuss how we figure all that stuff out. So multiple forms, one variable squared, the other one is linear. All right, now let's go back. So we have multiple forms of what this could look like. The general form for a parabola, which would open to the side, would be y squared equals 4ax. And again, that specific equation is derived from using a distance formula from the focus or from the directrix. Technically, it doesn't really matter because it's going to be the same thing. So that's how you would actually get that. If you were doing this with regards to a standard parabola where the x is the part that's squared, same general idea. The only difference now, instead of having an x on the other side, it's going to be a y, so it would be x squared equals 4ay. Okay, and that's it. Now, this would be a parabola here that opens to the right. So in other words, I can do a real quick sketch of something like that. That would be a parabola which opens in this general direction. One thing you need to understand about that is that a parabola which opens to the right is not a function. Okay, it fails the vertical line test at almost every single point. But it is an equation. Okay, it's definitely an expression. It's going to give you a graph. It's going to be a graph that opens to the right. The one that we have below that is your standard parabola, because if you were thinking of this as a standard parabola, you would divide both sides of x squared equals 4ay by 4a, and you would basically get that y equals 1 over 4a times x squared. So 1 over 4a, and this a, again, is just a value, it's a constant, is basically like your coefficient of the x squared. So that would look like your standard parabola that opens up. So that one would open up. And then, as you would probably think, that if you want something that opens left, you're going to make the negative 4a squared, excuse me, the 4ax negative. And if you want something that opens down, you're going to make the 4ay negative. So it would be a negative of each, and then it would open left or down depending on which one you're using. And then the last part of the parabola we're going to talk about before we actually get into doing some examples of what we're going to try and do here is this thing which is called a latus rectum. I know it's got kind of a funny name to it. And there are more applicable, let's say practical applications for this than what we're doing. We're just actually going to use it to help us graph. But basically the idea is if your focus is here, and that's a distance away from the vertex. So again, that would be the point 0a. The latus rectum goes right through the focus and connects to the parabola in two different places. So the one thing that you know about that is that no matter what, your y value is a. It's the x value that you would have to determine. So you know that your y value here is a. it's the x value that you would have to determine. And, you know, whatever the x value is, it's going to be the opposite on the left that it is from the right. So they're going to be exactly the same x values, but opposite signs. So we'll just say that this one is a positive x, and that this one over here is a negative x. And this line in particular is called the lattice rectum. And really, for our purposes, we're only going to use it to help us graph this, even though you don't really have to use this. You could use any other points that you wanted to on the parabola to help. That's just a convenient one. And again, that has other practical application uses, which we most likely won't really be going into very much. But it's definitely something interesting you could look up. All right, so let's look at a real quick example. Basically, what we're going to be asked to do is write the equation of the parabola given some information, and then we're going to graph the equation. So let's see, example 1 here. So we're going to find the equation of the parabola given that the vertex is at 0, 0. Eventually we'll do some where it's not. The focus is at the point 3, 0. And then we want to graph it as well. So it's good to be able to figure out, okay, well, from this, how do I know which way this thing is going to open? Well, if you just kind of go to your sketch here, you know the vertex is at the origin. And then the question is, does it open up, down, left, or right? Well, the focus is the part that's going to tell you that. Since the focus is the point 3, 0, you have a point out here, which is your focus, which tells me that this thing has to open up to the right because the focus has to be within the concavity, or basically the bowl shape of the parabola, if you want to think of it more practically. So we know it's going to open to the right, which means that we are looking at an equation, y squared equals 4ax. So when it opens to the right, or to the left, the y part is the part that is squared. When it opens up or down, just like a normal parabola, it's the x part that is squared. And I say normal parabola, but it's the parabolas you've been used to using. All right, so how do we find all this information? Well, the a value, it represents the distance from the vertex to the focus. That's what a is. So a is the distance from the vertex to the focus. And in this case, the distance from 0 to 3 is 3. So in this case, a is 3. So we know that y squared is going to equal 4 times 3 times x, which means that y squared equals 12x. Again, not the most common way that we're used to seeing these or writing these. Technically, if it was me, I would actually want to divide both sides by 12, and then I would get that x equals 1/12 y squared. To me, that would actually be easier for me to write as an expression of this equation. But either one is perfectly fine. So the top one, the y squared equals 12x, is still perfectly fine. So now let's see, how are we going to sketch the graph? Well, in order to sketch the graph, what you really need is 2 more points, one on either side of the focus. So that's why we use the idea of the lattice rectum. The lattice rectum occurs when, in this case, x is 3, because it's going to be at the same location as your focus. So when x is 3, we're going to plug in, we'll use this equation for this. This will make it much easier. 3 for x, so we get y equals 12 times 3, or 36. That means that y, taking the square root on both sides, is going to equal the positive or negative 6. So that gives us 2 points. We now have the points 3, negative 6, and 3, positive 6 that we can sketch on our graph. So let's see here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I'm going to go out to exactly the same place that I had the focus, and that was 3. So 3, 6, and then 3, negative 6. And now we can basically sketch our parabola going through those 3 points. Okay, and then the one thing that we didn't talk about is the directrix. And the directrix should be exactly the same distance away from the focus, from the vertex that the focus is. So the directrix should be back here, 3 units back, 1, 2, 3 units back. And again, I just approximated. But the directrix should then be an equation because it's a line. In this case, it's going to be a vertical line, simply where x is -3. That would be your directrix. And now we have sketched the graph of the equation as well as writing the equation, which was one of these two right here. Either one, perfectly fine. So now let's say for our second example that we're actually given the equation of the parabola. And it's y squared equals 8x. So the first thing you notice is the y is the part that's squared, so we know it's going to open left or right. The right-hand side of that is positive, so it should open to the right, unless we're missing something completely from the problem, but that's the way it should open. So in this case, we actually want to find some information. We want to figure out where the focus is, where the vertex is, and all that kind of stuff. So let's take a look at what information that we've been given. Remember that the general equation is y squared equals 4ax. Well, the 8 has taken the place of the 4a. So now we have a way to find a. We just simply set 8 equal to 4a, divide both sides by 4, and we get that a equals 2. And remember that a is the distance from the vertex to the focus, so now we have the location of our focus. And again, this was an equation that we know should have opened, and I'm just going to do a real loose sketch of this to the right. I'm not worried about finding the latus rectum or anything like that in this case, but we do know that a is 2. So that point right there would be 2, 0, and that would be your focus. So the focus is the point 2, 0. And the directrix, because again, it's got to be the same distance away from the vertex, but on the other side should be the equation x equals -2, which would be 2 units to the left. And there you have analyzed some of the information that you have been given. Again, hopefully that makes sense. Let's try one more of those. Oops, come on, extend. There we go. So example 3 here. So now we're going to be given x squared equals -12y. So in this case, you should look at this and say, okay, this is an x squared. So this is the parabola that I'm used to seeing. It's either going to open up or down. The fact that the right side of this is negative tells you that it opens down. So again, if you just wanted to do a real quick sketch, you know that it's going to open down. Now, I do want to make sure that we see that this is going to, the vertex is going to be at the origin. And how do we know that? Well, in this case, if you plug in 0 for x, you get out 0 for y, or vice versa. So you know it's going to open down. We need to find the focus, so we need to take the -12 part and set that equal to 4a. Dividing both sides by 4 gives me that a equals -3. And again, that makes sense. Now remember that a is technically a distance, so the fact that it's -3 just tells you the direction the focus goes in. So the focus is going to be down here at -3. So your point would be 0, -3. And then your directrix would be 3 units away up here, which would be the equation y equals +3. So the focus is the point 0, -3, and the directrix is the equation y equals positive 3. And that's the general idea if you're given that kind of an equation. Okay, let's try a couple real quick where you're given, in this case, we're going to give you the focus and the directrix. So I'm going to tell you that the focus is the point 0, 4, and the directrix is the line y equals negative 4, and we just simply want to write the equation. So again, the fact that your focus is a y value and the y equals negative 4 is the directrix, that tells you everything you need to know as far as whether it opens up, down, left, or right. Because the focus is a y value and the directrix is a y equals, that's going to open up and down. And because the directrix is negative and the focus is positive, it should open up. So we know that we're going to have a positive equation for our parabola here. So we just start off with the basic idea. First of all, it's an x squared equation because it's going to open up and down, and we know it's got to be 4ay. And if you see that the focus is at 4 and the directrix is at negative 4, well, halfway in between those, or the equal distance away from those, is at 0. So we know it's got a vertex at 0, 0. And again, that will change for some of these future examples. And then we can use the fact that a is 4, because that's the distance from the vertex to the focus, to plug into our equation. So we know that x squared is going to be 4 times 4 times y, which is the same thing as 16y. So x squared equals 16y is the equation. And that's pretty much all you need to write the equation. Again, if you choose to put that in a more familiar form, you could divide both sides by 16, which would give you 1/16 x squared equals y, or y equals 1/16 x squared. And you've written the equation. And of course, you could use the lattice rectum to sketch extra points. I'm not going to sketch this one. This was just about coming up with the information. All right, one more of these, and then we're going to shift the vertex off of the origin. All right, so let's see. We're going to be given that the vertex in this case is 0, 0, and the axis of symmetry contains the point -1/2, 2. And what we want to find is the focus and the directrix, and then the actual equation. All right, and one thing I did forget to mention, I apologize, I forgot to mention this back when we first started doing the graphs of these things. I'm going to scroll all the way back up. The axis of symmetry, let's go with the first one we did here. All parabolas have an axis of symmetry, which basically just cuts it in half. Let's do purple for this. But basically, the axis of symmetry goes right through the vertex. This is probably something you've heard before, but it goes right through the vertex. In other words, if I were to draw that dotted line right there and fold the graph over the axis of symmetry, it would be exactly the same either way you fold it. And it's because it's a symmetric function, or a symmetric equation in that case, because that was not a function. So the axis of symmetry basically cuts right through your vertex. And the one thing that I left off here, I did tell you that the axis of symmetry contains the point -1, 2, and is the x-axis. Because in this case, it would be very important for us to know that the axis of symmetry actually goes right through the x-axis. Yeah, there's something wrong with what I wrote here. What did I do? Oh, I see what it is. Geez, it's because I'm having a hard time sometimes reading my own notes. I apologize. The axis of symmetry itself does not contain the point -1/2, 2. The graph of the parabola contains that point. The axis of symmetry, okay, let's do it this way, is the x-axis. The graph of the parabola contains that point. Yeah, let's do it that way. Otherwise, what I just said actually made no sense whatsoever. So you got a vertex at 0, 0. Axis of symmetry is the x-axis, which means that we know this thing is going to open up to the left or to the right. We just have to figure out which way it's going to open and all that kind of stuff based upon the information that's given. So given the fact that the point is -1/2, 2, I'm just going to kind of sketch where I think that that point should be. -1/2, 2 would be 1/2 to the left of the x direction and then up 2. Well, that tells me that this thing has to open to the left because of symmetry. Then I also have to have a -1/2 positive 2 someplace. So again, just a real quick sketch, it would look something like this. So my focus has to be to the left, or a negative value on the x-axis, and your directrix is going to have to be to the right, or a positive value on the x-axis. So again, this one is going to be one where it's the y squared. So y squared equals 4ax. In this case, we don't know the distance yet for a. We need to figure out a. Well, we do have information to do that because we do have a point on the graph that I can plug in for y and for x and then be able to try and figure this out. So I am literally going to do that. We're going to plug in 2 for y, and then we're going to plug in -1/2 for x, and now we can solve for a. So that's going to be 4 equals 4a times -1/2. I guess I just could have multiplied the -1/2 at that time, but that'll be 4 equals -2a. And then dividing both sides by -2, we get that a equals -2. So now I have the equation y squared equals 4 times -2 times x, or y squared equals -8x. So there's my equation. And since we know that a is -2, your focus is going to be the point -2, 0. That's the focus. And your directrix will then be the point, or excuse me, the line x equals 2. All right, and we've done as much analyzing of that particular graph. Again, we could use the whole lattice rectum to get a couple more points if we wanted to, but I think we're good for that one. All right, so this was a relatively lengthy video, so we're going to come back with another one, hopefully a little bit shorter, but it's going to involve shifting the parabolas off of the vertex being at 0, 0, as well as how to use completing the square to get some of our information as far as writing the equations. We'll come back with a second video.